All right, guys, welcome back. Today we're going to be talking about graphing. And you may be thinking, Miss Vance, don't you dare get that math in our science class. How dare you? We really need to know how to graph for science because this is just how we are able to show our information or our data in a visual way. Also, when you take your LEAP 2025, you're going to need to know how to look at a chart or a table or a graph and draw information out of that. So by the end of today, we should be able to put together a good graph, understand a graph, and use some of our electronic tools to create one. So let's get started. So a graph. You probably know a lot of this already. Hopefully most of this is review for y'all. So you see up at the top over here, we have the title of the graph. A title should always talk about what the data is. Don't just name it something random. That title should tell me what I'm looking at. So just by looking at this graph, I should be able to have a general idea of what the data is about or what the experiment was about. So if you have all different kind of colors or you're graphing more than one thing at the same time, you'll want a key up in the upper right hand corner. You're also going to want to make sure that you have your y-axis and your x-axis labeled accordingly. A sample graph is actually something they didn't do right. They didn't necessarily tell me what was going on the y-axis and the x-axis, and we know we can do better than that. So let's take a look at these things a little more in depth. So a good graph should always have, like we said, a title that describes what the data is about. Not a random title. This point scored, I probably would have been more specific than that. Points scored during the playoff game for the 2020 school year, something to that effect. We need labels on our X and our Y axis, and our intervals should be consistent. So what that means is if you look at this graph on the slide, there's 25 points between each line. So it goes 0 to 25, 25 to 50, 50 to 75, and 75 to 100. These intervals are even so that when we're looking at the graph, it makes sense. So the relative height of one bar compared to the other one makes sense. All right, so when we're graphing, this is going to be connected to our variables. The independent axis, or the independent variable, sorry, goes on the x-axis, and the dependent goes on the y. So here's another graph example. They measured CO2 or carbon dioxide emissions during park operations for like a national park. So they measured the amount of CO2, so that makes it the dependent variable, and we see that they put that on the y-axis. And on the x-axis, they were looking at different modes of CO2 emission. So those things they controlled. They can control if they looked at energy, if they looked at transportation, if they looked at waste. That's what they are testing. So they put that on their x-axis. All right, so there's three main types of graphs that we're really going to be worried about. There are a lot more ways to present data, but this is going to be just for this lesson what we're going to focus on. There's bar graphs, and those are generally used to compare a series of one-time results. So if I did an experiment and I wanted to see, I don't know, how many of each color of Skittle there was in a bag, that's a one-time set of results, so I can measure that with a bar graph. A line graph, however, shows change over time. So if I wanted to show how many students were left in a game of dodgeball over time, I could use a line graph for that. And then a pie graph, wow guys, sorry. A pie graph compares parts of a whole. These ones are a little more complicated to make. Generally, we don't focus really hard on doing that because you have to know a little bit about circles to do that. But if you want to see like percentage out of 100, that's when we use a pie chart. All right, so how we graph a data set. So first, we need a set of data. We have to look at what information we have. So what sort of data graph would best represent it? What sort of graph could best represent this data? Sorry. So if we used a stopwatch to check results over time, we might use a line graph. If we did a survey and got results from a group of people, we could use a pie chart or we could use a bar graph because there's some overlap there. If you're counting the number of thunderstorms each month, you could use a bar graph or a line graph. Again, it depends on what I'm trying to show, what I want to do with it. So here's some sample data, zodiac signs, and the number of people who answered that they had those zodiac signs. So we could use a pie chart for this data, or we could use a bar graph. Probably you're most comfortable with bar graph, so that's what we're going to look at first. So the first step for your graph, or the second step, is to draw your axis and label it. I hope you guys appreciate how much time I spent in Google Slides hand drawing this, but yeah. So remember, independent variables, so what I'm studying goes on the x-axis, and the dependent variable, or my results, go on the y. So I titled it Frequency of Zodiac Signs. You could look at this graph, not know anything about the study I did, but you could look at that graph and say, okay, I know what's going on here. Number of people is what I labeled my y-axis, and then zodiac signs are what's going to go on the x. Then I need to create my scale. So a good scale is going to be spread out enough that I'll be able to notice trends. I don't want to have these super big intervals. So if I did my intervals every 20 for this one, like it goes 0 to 20, 20 to 40, then I won't be able to see a trend because all my little bars are going to be so tiny, I won't be able to really see anything. So I used intervals of 2 because I felt that could represent my data the best. So 0 to 2, like I did, that works well. Intervals like 0, 5, and 10, those are even. So those, well, even that one, you see I made a mistake there. We need a 15 in there, don't we? So if they're even, they have the same amount of numbers between the two, that's good. If it's all over the map, that's bad. So next we need to draw our bars. And remember, when you do a bar graph, the top of that bar needs to match the number from your data. So I can look at this. I don't even need to know anything about my data chart, and I can already tell all that same information here. Oh. For other types of graphs, so line graphs, you don't do that as much. In the past, I've noticed that students are a little intimidated when an experiment calls for a line graph. The steps 1 through 3 are exactly the same. The only difference is instead of drawing bars in step 4, you put a dot where those data points would be, and then you play connect the dot. You can also do more than one set of data on the same line graph. So you would do one set of dots, connect them with one color. Then you can go back and do another set of dots. Let's say one was the change over time with my control group, and one was change over time with my test group. They could both be on the same graph, just in different colors. So we can do that way. So pie graphs. We're not going to focus a super lot of time on this just because they're not needed as often, but you do need to understand them a bit so you can read them. So a pie graph is going to show you a percentage of a whole. So first, to make one, you have to figure out what percentage of the whole each part is. So I added up our data values, and there were 40 people total. So I need to figure out how much out of 40 each of those is. So 12 out of 40 for Capricorn is 30%. I showed you the math on the slide. So once I figure out that Capricorns are 30% of the total number of people, then I have to figure out what 30% of that circle is and carve that out. It's a little bit complicated, but you need to be able to read it. So if I saw this, I would know by looking at this pie graph that about this chunk out of the whole was people who answered Capricorn. So next I want to show you, if you choose to draw these in a slide, a few of the tools that you're able to do with that. because you're going to have to do some graphing for practice for today's assignment, but you have some choices on how you do those graphs. So if you're using Google Slides, so I need to go back to edit mode. So here I am looking at a blank slide. If I want to draw a graph from here, I can insert lines. So these tables and charts, you have to connect that usually to a spreadsheet. If you know how to do that, cool. If you don't, you have to start from scratch like I did. So we're going to draw a y-axis, and then we're going to insert another line. And it lets us connect them, and I'm just left clicking and dragging it out. And so I have my X and my Y axis. So next I'm going to put some text boxes so I can label it. So if we were doing like the one that we had in the example, this would be zodiac signs. And if you can't see it like me, you can change the font to something a little more visible. Okay, now we're going to do this other axis. I'm not going to do all of this because I know you guys are probably sick of hearing the sound of my voice right now. So we're going to insert another text box. So this one was number of people. We'll make it to where we can read this again, which is just a good thing to get in the habit of. Make sure that you can read your work and other people can read your work. Okay, so now we want to rotate it. So there's this cool little tool up here, and it lets me rotate it like this. So that little dot up there, you hold it with your left click, and then you can drag it into place. Okay, so that's how you do it in Google Slides. There's something I wanted to show y'all how to use real quick. There's this website. It's going to be linked in your assignment, but you can make all different kind of graphs with this. We're going to click start over so we can go back to the beginning. But like I said, you'll have this link. So it'll ask you what kind of graph you want to make. So if I'm making a bar graph, I click bar graph. Okay, it's going to ask me some questions. Vertical means up and down. So that's usually what we do when we think of a bar graph, right? Let me move my face so that we can work on this. All right, so we like all that. Good, good, good. So then it has this tab, data. So I need to put a graph title. So like zodiac signs, my x-axis label. So that was zodiac signs. Maybe if I could spell, that'd be great. Zodiac signs. Our y-axis was number of people. And so then item label, that would be like our Capricorn, Aquarius, Pisces. Oh no, hold on. Pisces, Virgo. And then whatever numbers we had, it was like 12, 10, 5, 8. I don't think it necessarily matters. Okay, so we put in data. We did well with that. All right, so let's look at our preview. See, look, this will draw the graph for you. And if you want to use this graph, like to put it into an assignment or something, see this print save tab, I'm gonna click it. And so you can email it or you can download your graph. It depends. I would probably download it and then you can insert it into the document or whatever you need to do for your graph. So if I download it, I would pick PNG or JPEG. This is a picture format. So when you go to insert a picture into a slide or something to show me your graph, that would be the best way to do it. So I downloaded it. See, it downloaded right here. So I can click it and it will open up my graph and I can put it somewhere else. It'll load. There we go. See, there's the graph I made. All right, so that's a second way you can do this. So let's talk about a third way that we can do this. So here is an example assignment. It'll probably be the one that I assign. We'll just have to see. But we're going to open this PDF with Kami, which y'all have been doing a lot lately. So we're opening up Kami. So you saw that we went and we clicked open with, and we went down to Kami. Okay, so now we're going to scroll down to the actual assignment part. So we have graph the following information in a bar graph, label and number the x-axis and y-axis appropriately. So with Kami, I can do all of the things I would do with a pen and pencil on here. So I would want to make my text boxes so that I can label it. So we've got months and numbers of deer, and they expect a bar graph. So we left click, we make our text box, and we can label it. So what do we think would go on which axis? So I'm measuring deer, so that's going to go on the y-axis. So that means my months go here. And I can move this down. And so then you can go through and you can make labels for all of these. So I'm just going to do a couple to kind of show you. We don't need this video to go on longer than it already is, because I feel like I've been talking forever. So we'll have September. And we'll make another text box. I'll just do September and October to show you. When you do this, you got to do all of it. So just be prepared. Okay, so September and October. So then we need to make a text box over here. We got to label our y-axis. So this is number of deer. Okay, so we start, our smallest number is 12 and our highest number is 38. So we're probably going to have to number this all the way up here. And so either you can do text boxes, or if you're feeling good about this, you can write the numbers yourself. So we'll do like intervals of 5. Can we see that? No, that's bad. Make it a little bit thicker. So 5, 10, 15. So we'll number all the way down here. So when we go to make a bar, we can use the shape. So insert a rectangle. Well, okay. So let's erase these because those aren't what I want. So I'm just left clicking on the square that I didn't want, and the eraser will get rid of it. So September, we had 38. So I'm left clicking and I'm dragging, and I can drag up, see, 15, 20, 25, 30, 35, 40 would be about up here. So 38 would be close to there. Okay, so this is how you can draw your bar graph in here. If you have any questions on how graphing is going to work, or if you can't make one of these 3 ways work for you that you're trying to use, please contact me and let me know. Good luck with this assignment, and I will see you guys in the next video. Take care.